Hey guys, welcome back to Extreme IE. In this video, we're going to talk about vulnerability-based segmentation. Well, what in the world does that mean? One of the things that Tetration provides that's really cool is a vulnerability dashboard. I want you to take a step back for a minute and I want you to think about what an attacker is going to do when they come into your environment, right? They're not coming into your environment to just poke around and just look at cool things. They're coming in to steal something. They're coming in to wreak havoc. They're coming in to bring things down and use it for a ransom, right? They're coming in to deploy ransomware, or they're coming in to try and take a database. And they're not just going to come in and continually try to penetrate just any server. What they're going to do is they're going to look for where they're going to get the biggest bang for the buck. Meaning they're going to find machines, they're going to find workloads, servers, VMs, bare metals, doesn't matter. They're going to find things in your environment that they can easily compromise, that is going to give them the most amount of data, the most amount of buyback, right? So one of the things that we typically do here is we run what's called an Nmap scan. Now, I've done this. This is just a web wrapper, by the way. I'm sure in some of my videos you guys have seen this a bunch of times. This is just a free tool that you can download on the interwebs, right? You can download Nmap, you can put it on your laptop or whatever, your tablet, and you can, go to a college, you can go to a convenience store, you can go to Starbucks, and you can run this while you're connected to their Wi-Fi, and you'd be shocked at what you actually find. And this is exactly what an attacker is going to do. I'm not saying they're going to use Nmap, but they're going to use a tool like Nmap, or maybe they're going to use Nmap. And so I have a finance application within my environment here, and I want to show you just the process, the motions, right? We're not going to attack it. We're not going to compromise it. Just want to show you the motions here. So I'm going to go and I'm going to click on 242 here. And by the way, that was completely random. I don't know, in my finance app, I have no idea what servers are which here. And so you can see that this is a web server. How do I know that? Because I see Nugenix running over port 80. I see Apache running on port 8080. I see Nugenix again, a second instance of it running on 8081. So I can guess pretty good that this is a web server. Now, as an attacker, if Nmap comes back and gives me this data, all I need to do is look for Apache 246 and see what I can find. So let's say Apache. We'll say 2.4.6 exploits. By the way, you may not be able to see my address bar, but I am typing it. I'm just hiding some of the URLs here. And I'll click on this, the CVE details.com and go to all the different CVEs that are available, or that I should say that Apache 246 is vulnerable to, and I can start looking through them. I can start finding, is this susceptible to some remote code execution? Is there some script that I can run somewhere? Is there some way that I can compromise this particular web host? And so I have a problem within my environment, and that problem is that I have a number of different endpoints, workloads, in my data center, in my finance app. They're all VMs, and I have a problem because they're spread across different data centers. They're on different hypervisors. They're running on different infrastructure. I have Juniper in one data center. I have Cisco in another data center for routing. For switching, I have Arista in one data center, and I have Cisco in another data center. For hypervisor, I have Microsoft and Citrix Zen Server in one data center. And then I have VMware's ESXi in another data center. So I'm a mixed bag, right? I have this finance app running on all different types of infrastructure, all different types of hypervisors, and there may even be some containers mixed up in this. And so how can I, number one, how can I prevent this application from being attacked and scanned? Well, Tetration can do this in a number of different ways. The first thing I'm going to do is I'm going to go to my terminal server here, and I need to, pay no attention to the man behind the curtain here. I need to actually remember what URL for my application. So this is another cool thing that Tetration is really good for. So I've already mapped out this application within Tetration. So I've already asked Tetration, hey, can you map out my application? Can you show me how all of the flows work? Can you show me how the database tier is talking to the web tier? And can you show me where the terminal servers are accessing my web tier? I've already asked Tetration for all this data. So because I forgot the front end web server or load balancer that I need, I'm going to go ahead and just grab it right from Tetration. So we'll go into Tetration here. I'm going to go ahead and paste this in. We'll go ahead and hit enter here. And here's my application. So This is a freeware application. It's a free finance application. It's for invoicing, so you can see here that the application works. And I'm also going to go ahead and I'm going to open up a command window, and I'm going to say ping 172.17.17.229. And you can see that not only can we ping it, but we can actively access the application. So if I was an attacker and I was able to install some malicious software on this terminal server, you can see that I would in fact be able to not only access the application, but also be able to ping it. I mean, there's really no blocking it. If I wanted to SSH into this box, I could. And so let's take a look at how Tetration can essentially quarantine or block this particular traffic, or how can we begin to segment our data center. Now, Tetration here, I've built a high-level policy. And what does that high-level policy do? This policy is a global InfoSec set of rules that goes across my entire data center. So what it's going to do is it's going to be like an umbrella. It's going to be like a hierarchy, right? So let me give you an example of what that might look like. So here, I'm going to apply, you can see here that I have what's called a tree of all of my different applications. It's a scope tree. So I have my branches, my campus users, I have my container application, I have my demo app. You can see that underneath my healthcare, I have Epic, right? So I have various different trees, right? And you can see that these are the different branches. So I have my terminal servers, I have my shared services, and then underneath my shared services, I have Ansible, I have my domain services. And so Tetration operates based on a hierarchical policy model. So if I apply a policy here at shared services, inherently my IP address management, my jump box, my domain services, they're all going to get that policy that I'm applying to shared services. So I don't have to apply this across every single firewall or across every single entity in my data center. In Tetration, I can apply this at a high level and just essentially push it down to everything. So what I'm going to do is within my lab, I'm going to apply my policy at this level here in order to make everything else inherited. So going back to my global rules, I have a couple different rules that I just want to go through with you. I have my Ansible. Now my Ansible needs access to everything within my data center. That's my RFC 1918. And if you look at the ports here, we need access to Microsoft's remote SSL, and we need access to SSH. This is so that we can automate some of the things that we have in our environment. This could be any of your scripting libraries that you have today, right? This could be Python, again, your Ansible, it could be anything, your management tools, whatever. I'm also going to allow access to my Guacamole jump box. Now, when it comes to allowing access to your jump box, you don't just want to allow access to everywhere, every time, all the time. So you can see what I'm doing is I'm telling Tetration to allow Guacamole to reach only my Windows-based servers. And you can see here that I'm doing this based on operating system. So I'm telling Tetration, look, I want you to group together every Windows machine, whether it's Microsoft Windows, because I do have a Windows 10 VDI environment, or any Microsoft server, and I want you to only allow Guacamole to hit that box on 3389 remote desktop. I'm doing the same thing with CentOS, and so what I'm doing is, again, I'm saying, look, if the operating system contains the word Cent, you could do it more detailed. You could say CentOS. You could do it based on actual versions of CentOS if you wanted to. I'm only going to allow access to SSH. Now, these absolute policies are going to be, again, an umbrella across my entire data center. And then I have two default policies here that are only going to allow development to talk to development and production to talk to production. So in other words, if I don't consider you production, so I have 48 production endpoints or production workloads within my environment, and I have 530 development workloads in my environment. This is a whitelist model. And so only my development workloads will be allowed to talk to development. I will not be able to talk to production from development. So what I'm going to do is I'm going to go ahead and I'm going to enforce that policy. Now you can see here that Tetration does actually, you can just see that pop up. Tetration does have revision control. So let's say I enforced 14 or 15 different changes of this policy. Tetration would say, hey, which version do you want to deploy? And if I deployed a new version 15 and all of a sudden something broke because I didn't do my job, I could go back and I could deploy version 14. So we're going to say version 1. This is the only version of this policy that I have. And so we're going to go ahead and we're going to deploy it. Now, in the meantime, what I'm going to do is while that's deploying, in fact, I'm going to open up one of these web servers in another tab, and we'll be able to see these policies being pulled by the agents that are running. This is a pull model, so the agent checks in every 30 seconds, and then it takes about 30 seconds for the policy to actually be implemented on the workload. So this Linux web server right now just has allow policies locally. When it checks in the next 30 seconds or so, it will grab the new policies, it will deploy them, and then within about a minute, we should see them. In the meantime, we're going to get back to this idea of vulnerability-based segmentation. Now, and this is where we're headed, by the way. So again, when an attacker comes into this environment, they're going to scan that web server, or they're going to scan all of my servers, and they're going to try to figure out, hey, what can I leverage in order to gain access to this web server? But it's not just the fact that these web servers have a vulnerability. In fact, what I'm going to do here is I'm going to sort this based on only one application, which again is another thing that's cool. Because Tetration will show you this vulnerability dashboard based on your entire environment. So this could be multiple data centers, multiple cloud deployments. You know, I could have EC2 instances running in AWS. I could have 3 different data centers, and Tetration will group all of that together and show me an overall vulnerability dashboard, or I can narrow it down to a specific application, and that's what we've done here. We're looking at just the demo application. So again, it's not just that I have a vulnerability. I mean, you guys have vulnerability scanners in your environment that are doing this today. Being able to leverage that data to actually protect your environment is really important, because let's face it, most customers, most organizations, I've been there myself, are not really good with patch management. We're not really good at staying 100% up on our patches. But it's not just that we have a vulnerability. You can see here that I have 81 high severity vulnerabilities. It's also the access complexity. And what does that mean? Well, what the access complexity is how hard is it for an attacker to get into your environment based on that vulnerability. So if I see something that has a high access complexity, I'm not as worried as something that has a low access complexity. What does that mean? Well, if I have something that is a low access complexity, I'm essentially saying that it's easy for an attacker to leverage that vulnerability. If I come in here and I click this low access complexity, you can see that my high severity vulnerabilities have dropped down to 18. So now I have 18 high severity vulnerabilities, and I can sort them here if you want to, right? I can look through what those are. In fact, I have a critical one here. This is a 9.8, and it's low access complexity. So to me, this here is a vulnerability that I'm worried about. You can see here that it tells me which servers are essentially that have this vulnerability, and it also tells me what the vulnerability actually is, what's the package. I could sort this a little bit differently if I wanted to. I could look at the packages that are vulnerable, or I could look at the workloads. So within this application, can you show me, maybe it's not every server within the application, maybe I just want to see what those servers are, and maybe I want to look at what vulnerabilities are on a specific server and be able to sort them from there. So Tetration gives you a lot of different ways and angles to not only look at this information, report on this information, but also address it. So now I see that I have some critical vulnerabilities in my environment. In fact, I want to go back and look at my entire data center. So what I'm going to do is I'm going to just look back at my entire tenant in Austin, Texas here. And you can see here now I have 58 low access complexity and I have 21 high severity, right? And so again, this is something that maybe I'm really concerned with. Here's a vulnerability here that just came out in 2020. It's from .NET Framework, so it's obviously a Windows host. And look at this, this is our Windows terminal server. So what can I do here? Well, the first thing I'm gonna do is I'm gonna go back and I'm gonna refresh my page here. Let me just go to my web server here, give me a second. And we're gonna see if those policies have been downloaded by the agent, and they essentially have, right? So you'll see here that now my 2 allow statements have been set to drop. And now I'm only going to allow essentially production to production. So I haven't broken my app yet, right? My app is considered production. It's a production application. So since it's in production, it will talk to other production applications. We've allowed jump box access. So if I head back over here to my host, I'm going to copy this IP address so that we don't forget it. I'm going to close out of Internet Explorer. We'll open it back up again. And let me paste in the address. We'll double check that we can still gain access to the application, which we can. And I'm going to validate my ping request one more time, and essentially I am able to ping my application. So we haven't broken the app. what I'm going to do is I'm going to come in here and I'm going to refresh my Nmap Scan. So I want to see if I've prevented this unknown machine on my network that could be development from attacking my app, and I have, right? So now I've essentially quarantined my app from this rogue laptop or rogue machine on my network. By the way, Tetration does integrate with ICE, so I could do this based on SGT tags. So I could say, hey, is this laptop or is this user authenticated? If it's true and they are authenticated, allow them access to the app. If they're not authenticated and they're on the guest network or something like that, then don't allow them access to the app, and I can do that dynamically, right? And the thing with ICE is, you know, people will say, well, yeah, but I can do that with just ICE. That's true, but that means that your network, your campus network, has to have the ability to pass SGT, which means you may need to go spend quite a bit of money to upgrade your physical infrastructure out on the campus. Tetration can do that all in software without upgrading anything. Again, it's hardware agnostic. We don't care what kind of switching or routing you have. So we're going to come back here to Tetration and look at these vulnerabilities. And so now I have a problem, right, where, you know, I have an issue. I have a critical vulnerability in my environment, and it's low access complexity, and it's from my Windows server, my terminal server that my users are currently using. So if an attacker now is able to gain access to this terminal server either through that vulnerability, or, you know, they steal somebody's credentials and they're leveraging a vulnerability, whatever it may be, I need to prevent this from getting to my finance application. So that's what we're going to do. Now, I said before that I've already gone in and mapped out my application. So you guys, there's another video on my YouTube channel where, you know, we map out this application where we show you the rules essentially and how they're built. But I have a group here. This is my application policy, and you can see right here that I've thrown a deny in here, and I've changed it to the priority of 99. So before all of the allows actually are acted upon, I'm going to have this deny statement in here, and I'm going to deny any machine, any server that has a specific criteria. So what I'm asking Tetration to do is identify any CVE that is a 9.5 and above. If you remember in let me go back to my vulnerability dashboard here. If you remember in the vulnerability dashboard, that vulnerability was a 9.8. So what I'm asking Tetration is, look, anytime you see a 9.5 or above, that's a greater than symbol, right? And the access complexity is low. So what Tetration is going to do is it's not going to care for any vulnerability that's 9.5 and above. It's not just going to care about low access complexity. It's going to look for both of these. If it sees a 9.5 or above and the access complexity is low, it's going to flag that endpoint. But if you remember, I had a number of my application servers that are all Linux that are also vulnerable, right? They also have some internal vulnerabilities. And so what I'm going to do is I'm going to sort this, again, based on operating system. So now I'm asking Tetration to look for 3 different criteria and then throw that server into its own little group. So if it's a Windows server, right, if it's an MS server, and it has a 9.5 vulnerability or above, and the access complexity of those vulnerabilities are low access complexity, I want that in a group. And then I'm going to deny that group access to my finance app. But we're not going to break the app. So I'm still going to allow the application to continue to perform. So if I come over here to my application map, and I just expand to make it a little bigger for you folks, I'm still going to allow the application to perform as follows. I'm going to allow the web tier to access the database tier. I'm going to allow bidirectional traffic for the app tier. I'm going to allow the app tier to access the database tier. So you'll see that I'm still going to allow all of this cross functionality to take place, but I'm going to end up denying my Windows terminal server access to this application. Now, before I do that, I want to come over here to policy analysis because I want to look at all of the traffic that essentially I'm going to reject. And you'll see here that what time is it? It's 9:47 my time, right? You'll notice here that I can begin to see different endpoints and different machines that we're going to block. So I have 16.1.14. This happens to be that rogue machine where I'm running Nmap on. And you can also see here, let's see if we can find that terminal server anywhere. And here it is down here. So the policy analysis within Tetration is letting us know exactly what we're going to block before we actually do it. It's telling us, look, if you do this, you are going to prevent this terminal server from accessing this app proxy server on port, on HTTP, and here's the policy, here's the services that are involved. And so again, on that HA proxy box, it's a load balancer, right? Here's the services that we're going to deny being able to access. And so Tetration does a really good job at analyzing your policy and letting you know exactly what is going to break or what is going to stop working before you actually enforce the policy. So enough yapping. What I'm going to do is I'm going to come over here. I'm going to enforce this policy. Again, version control. You can see I've enforced this policy a number of different times. I'm going to go ahead and say version 13, and I'm going to enforce it. Now you'll notice here that I'm enforcing multiple policies at once. Again, this is due to the hierarchy of Tetration, the hierarchical model of being able to enforce policies. So I'm enforcing one policy globally across the entire data center. Every single server in my data center is receiving this policy right now. But then I want a separate, more fine-grained, more detailed policy on my application server that again is going to prevent access to my terminal server. Now what I'm going to do is I want to go and grab, I think I had the vulnerability dashboard up. What I'm going to do is I'm going to grab, let's pick one of the database servers. Let me just go over there. So I'm going to look at the database server. I'm going to go over to the policies tab, and what I'm going to do is I'm going to pause the video until the policies get pushed. So here's my database server as it exists today. We're going to wait a minute and see those policies get pushed down. Okay guys, so we only had to wait about 30 seconds or so, and the policies were pushed right down. So essentially by the time the video stopped recording, the policies were ready. So now you can see all these policies that this database server has essentially downloaded from Tetration. Again, it is a download model, it's a pull model, it's not a push, and the updates happen every 30 to 40 seconds depending on when the agent is going to check in. It checks in every 30 seconds. But you can see now that I have all these different policies within my environment on this particular database server that have been pushed, or I should say pulled down. There's a number of different pages of policies. You can see all them. This is the one that we're mostly concerned about, though. This is the one that shows us exactly what we want to see. We're saying prevent any low access machine or prevent any critical CVE and low access, prevent it from seeing our database server. And you can see here that we do have some traffic. We do have about 480 bytes and 8 packets that have been seen. We could dive deeper into this if we wanted to. You can see here that these are hyperlinks, and so a lot of times people say, well, how do I know what's actually being blocked? I'm just seeing this name, but I don't know what that is. You can select the hyperlinks here, and that will show you exactly what's being blocked. Exactly what machines are within that IP address or what IP addresses are in that group. You can see that we do have some statistics here, bytes and packets. If I click this button here, all of the rules across the entire application will go ahead and download their statistics so we can see what the stats are on each rule. But here's what we're going to do. I'm going to go back to my jump box here. I'm going to close down Internet Explorer. I'm going to close down my my command window, and I'm going to open back up Internet Explorer. We're going to paste in that IP address. We're going to hit enter, and we're going to see if I have access to that application. It does not look like I do. Nope. Let's open up my command window, and I'm going to say ping 172.17.17, what is it, 229, right? And I'm going to go ahead and try to ping it, and I do not have access to it. So now, again, we've prevented access to my application dynamically. We've done it based on the fact that this machine is vulnerable to a specific vulnerability. Now, a couple things could happen here. I could go in and I could fix the vulnerability, I could patch it, and essentially Tetration would dynamically allow access from this terminal server. I could go in and I could change the criteria. I could tell Tetration, hey, you know what, oops, my bad, right? I didn't mean to say prevent Windows servers. I could add an exception here and say, anytime it's a Windows server except for terminal servers, I could do that as well. There's a lot of things that I could do here to essentially refix this, right? But the point is that we've achieved our goal. We've prevented access from a vulnerable machine with low access complexity from accessing our particular environment. Now, there's one more thing that I'm going to do, and you'll forgive me here. I'm going to pause the video, and what I'm going to do is I want to open up my jump box because I want to prove that the application still works. So I apologize for the little screen glitch there for a minute. What I'm doing now is I want to actually log into the application, and I want to see if it works from my jump box. So we're going to say 172.17.17.229. Here's my finance application, and I missed the username with 1P. So there we go. We're not going to remember it, and the application still works. So again, you know, we've achieved our goal. We've prevented access from that vulnerable terminal server from accessing our application, yet the application still works. We can still reach it from our jump box, and any machine that does not reach our vulnerability criteria will still be able to reach the application. Hope you guys enjoyed this video. Talk to you soon.